So we define the torque as following. The mathematical definition of the torque, we use the letter tau. This is the equivalent to T in the Latin alphabet. Tau. We're going to say that the torque will be R cross F, where so F is a force and R is some kind of lever. Okay, and of course the torque itself is a vector, as the cross product is a vector. Okay. The magnitude of the torque is given by the following. We're going to write that the magnitude is the magnitude of the cross product, and we know that the magnitude of the cross product is the magnitude of the lever R, the magnitude of the force F times sine theta, where theta is the angle between the lever. The book called the lever is a position vector. I can go along with that. We write the position vector okay, I put it in parentheses, and I use the word lever and the force. So if, for instance, we have some kind of a ratchet or a tool, like so, and here we have a socket and we are trying to torque a lug nut or anything, and what we do, we cause rotation about this axis, right? So we apply a force, let's say in this direction, like so. So this is my F. The vector that, this is the axis of rotation, so this will be the sort of the origin. So we can place the origin right here, the connection between the two, and this vector, I'll use different color, that is the lever or the position or the distance between the axis of rotation and the position where we apply the force is the vector R. Okay. Now this is not necessarily 90 degrees. The angle here is theta. And we create the torque by applying this force and causing rotation. Of course, the rotation going to be this way. Okay. Notice that this is the right hand. We follow the right hand rule because we have R cross F, and the result of the torque, the direction of the torque will be going into the paper. So the result would be a vector in this direction, and this is the torque vector. Okay, again, use the right hand rule. R cross F, R cross F, result torque in this direction. Again, R cross F give you a torque in the direction of the thumb. Okay, R is in this direction, F is in this direction, the result will be a torque in the direction of the thumb. Remember, the result of a cross product is another vector. And that vector will be perpendicular to both R and F. One thing to notice, what would be the units of the magnitude of the torque? Well, it will be unit of distance multiplied by the unit of force. But we have another combination of distance and force. For instance, force multiplied by distance gives you work, right? So not to confuse the two, the order is important. When we have work, we use first of all, we use joule, but we can use also Newton time meter, right? Force time distance. When we describe torque, it's R cross F. So we have meter times force. Indeed, if you look at torque meter, you'll see foot pound, not pound foot, or you'll see meter Newton, not Newton meter. The distinction between torque, unit of torque, and unit of force. I don't know if you got to it in physics, but those of you who learn torque in physics probably learn this distinction between the unit of work and the units of torque. Something to be mindful of. The calculation itself is pretty straightforward, I think. Let me give you an example here. Before we go to the example, notice that the angle here is not necessarily 90 degrees, but the component of the force that really affect the torque is the component that is perpendicular to R. So that's why the magnitude has this component F sine theta, but we'll look into that by the following example. Okay, so we go like this. A bolt is tightened by applying, so let's write a force of 40 Newton is applied to a 0.25 meter range to torque something. Okay, we want to find the magnitude of the bolt, of the torque. Well, the magnitude of the torque, it's R cross F. It's also, since we don't have the vector, we don't have the direction numbers or the component of the vector, all we have a magnitude, we have to use am I missing something? Let's see. I think I'm missing the angle. Oh, there is a drawing. And we go back to this drawing and also, I made a mistake in the previous example. The measure of the angle, we measure the angle between R and F like so. Okay, the direction of R is in this direction. So this is the angle theta. So the angle here is 75 degrees. So it's a straightforward. We have we have R is 0.25. So we have 0.25 times 40 times sine of 75 degrees. So the rest is just simple calculation.
So what is theta? What is that located?
Theta, this is the direction of R, and this is the direction of F. Theta is in between. Okay, so this is theta, 75 degrees. This is the direction of R, and this is the direction of F, and that's how we remember. R is our we do R cross F, so we start measuring the angle from the direction of R, and then we go to F, and that's theta. So this was this example.